And I think I'm going to get started with this. Okay, so this first question is something called an exponential equation. The x, what we're looking for, it happens to be in the exponent. And what we see is that the base, the number that has the exponent is 4. So we're going to try and put the other side, the 64, also write it in what I call base 4. Write it as 4 to some exponent. Now you can use your calculator to help you with this by just doing, or you can do it on your hands or just thinking. 4 times 4 gives you 16, and 16 times 4 gives you 64. In other words, we can write the 64 as 4 to the third power. So we get that 4 to the 1 plus 2x power is the same as 4 to the third. Obviously, since the bases are the same, the exponents also should be the same. So the 1 plus 2x should equal 3. Look, as soon as you have both bases the same, and remember, if there's no exponent, it's understood to be an exponent of 1, then just set the exponents to each other, and then just solve that equation. So I'm subtracting 1 from both sides, which is giving me 2x equals 2. And therefore, our answer is x equals 1. I think that's exactly what you sent me, Cheryl. Very good. Excellent. So the answer to this first question is 1. Of course, if this is a multiple choice question, you could have taken each of the answers. Let's say you tried one answer, x equal 1. So you do 1 times plus 2 times 1. That gives me 1 plus 2 or 3, and 4 to the 3. Oh, it gives me 64. That must be the right answer. So you could do it by just picking out the answers and seeing which one actually works. As I did it as an open-ended question. So I didn't give you the choices, so therefore you had to actually work it out. Okay, here's that one. So now let's look at this one. Log base 25 of x equals a half. So this was an exponential equation. This happens to be what we call a log or logarithmic equation. And Jennifer, in this case, there is a subscript written in. It's 25. If no subscript is written in, this is the last thing I actually talked about. If it just says log and there's no number underneath it,
it's supposed to equal to 10, right?
Then it means that
I did the whatever I was supposed to do, and I didn't get it right. Oh my God, I was so mad.
I'm gonna do one like that in a second, but let's do this one. In this case, the exponent is given to us, and if we remember, here's the basic thing that we have to remember. If we have the log of, I don't remember the letters I use, let's call it base B of A equals C. This is log format. Then, as I said, most of the questions, not all of them, but most of the questions you can answer about logs if you switch it from what's called log format to exponential format. Remembering the subscript, the number down here is what we call the base. And again, if there's no number written in there, that means the base is going to be 10. The number on the other side of the equal sign, which in this case is the C, that becomes my exponent. And the number that's right next to the word log, not a subscript, but right on the same level, that's going to be what's on the other side. So this translates to this. This is log language. This is exponential language, saying the same thing in two different ways. Let me see if I can give you an example. I could say something like this. 2 plus 3 equals 5. That's one way of writing this. Or I could say 3 equals 5 minus 2. It's the same information. It's a different format. This is an addition format. This is a subtraction format. That's what happens with logs and exponentials. Two statements that are saying the same thing, but in different formats. Of course, over here in the exponential format, what you concentrate on getting is what the final number is going to be. Whereas in the log format, what you're concentrating on getting is the exponent. That it's only, but really basically they both mean the same thing. So for this particular one, the base is going to be 25.
I have a question. I'm sorry.
Yeah,
For the log 25, can you put that in a calculator or no?
did I?
For the log 25 for the solve, would you be able to put that in a calculator or no?
Um, you, let me, I didn't really talk
Yeah,
about,
I tried the same thing last night too. And yeah, I don't know.
tell you how to use the calculators. A little bit, it depends on which calculator are, but let's do this without a calculator. And the very next thing I'm going to talk about is the calculator.
Okay.
Okay.
Yeah.
Okay. So let's do this. And there are ways of doing things on the calculator, but some of these are really easier to do without a calculator. So if I'm switching it from the log format to the exponential format, the subscript is what we call the base. The number on the other side of the equal sign becomes the exponent. And that equals what's written right next to log, which in this case is x. I have changed this log equation to an exponential equation. Now, of course, you could do this on your calculator. If you want to do this on your calculator, you would put in your 25, then you would press what's called the exponent button, which usually looks like a little arrow pointing up, but some calculators have a different, if you don't know which is your exponent button, you'll have to send me a picture and I can figure it out for you. But you push your exponent button, and then since this is a fraction, you're going to put a parentheses 1 divided by 2 and press equal. And if you do that, or you think it out, what the 1/2 exponent, that's why we spend so much time, or we really did spend time working with the different rules of exponents. We remember a fractional exponent is the same as a square root. A 1/2 exponent means the square root of 25, and you're right, the answer is 5. You're right, Jennifer. In this case, the answer would be 5. Is this clear? Okay, so I'd like to erase this. I'll leave this on the board because this is so basic to what we're doing. And I'm going to erase this. I'm going to put on one more example because this is similar to the type of question that you were asking me, Jennifer. What if this was the question? Suppose I ask you to solve log 5x equal 3. Suppose that was the question that I asked you. Okay, I'm going to give you a minute to think about this. Okay, let's think about this. This is again a law question. As I said, we're not so familiar with logs as we are with exponents. So I would say at least 80% of the questions that are asked on logs, if you switch them to the exponential form, become much simpler. So let's see how we would write this in exponential form. Now, in this case, there's no subscript. This is what's called a common logarithm. Common logarithms have a base equal to 10. The base of a common logarithm is 10. And actually, when you use common logarithms, you don't even have to write in the base being 10. So if I would have written it the way I wrote it before, it probably should have been written this way: log base 10 of 5x equals 3. That missing base means it has to be, it's not a mistake. It means that the base has been used as 10, so we don't even bother writing it in. It's like writing x and meaning the exponent is 1. You don't write in the exponent of 1. It's understood. The same thing here. If the log is written without a base, it's understood that the base is 10. And of course, then switching it to exponential form, my base is going to be 10. My exponent is a number on the other side. That's the 3. And that equals what's right next to the word log, which in this case is 5x. And now I just have to solve this equation. 10 to the third is 10 times 10 times 10, which of course gives you 1,000. So this means 1,000 equals 5x. And to figure out what x is, it's just a regular equation now. I get x equals 200, which is exactly what you wrote, Emma. Thank you. So are you better on this now, Jennifer?
Yeah.
Okay.
I see what's going on.
Okay. Just remember, if their base is not written in, it's there, it's just invisible. So you can make it visible and then just write it.
I just want to say something. Maybe I just want to make it seem like it's clear to me. It's kind of like substitution in a way, correct? 5x equals to 3, and then maybe I'm just trying to understand, like, how did you get to 10? Maybe because the common base is 10, right?
Right. When there's no base written, if there's a number here, a little subscript, that's your base. If there's no number written there, then it means that the base is 10.
Okay.
And again, we just use this rule to switch it from the log form to the exponential form. I'm emphasizing this because you just have to think. If you think about the word log meaning an exponent, this will say to you the exponent that you put on base B to get A is going to be C. The exponent, the log is the exponent. So log equals C, your exponent is C. Keep in mind what is your base and what is your exponent. If you know what the base and the exponent are, of course, then that has to equal the third number. There are always 3 numbers involved. If you only see 2, it means that it's a common log and you have to put in the base of 10.
Okay, thank you.
Everybody okay with this now? Okay, so let's go on to talk about, since people have asked me, can we use our calculators? And a lot of it depends on which calculator you have. What I'm going to do is give you, okay, because you're confused. Okay, you don't want me to go further yet. Okay, because you're having a conversation with me. What part is confusing you? You don't get how to switch. Okay, that's a very general question. Let's just do, you know what, instead of my going on to the next step, let me just do a couple more of these examples. Maybe it'll catch on. Okay, we have a few minutes. Let's do some questions. Suppose I gave you this question. Log base 2 of 16 equals x. I'm going to give a few examples of these log questions where I'm going to put the x in different places, but you'll see that they all basically end up just being something about exponents. Okay, but Shira, remember, this is the rule. If you have a log, if it says log base b of a equals c, we translate it to b to the c equals a. What does that mean again? First of all, the subscript, the number that's a little bit lower, that is a number that we write, that's a number that's going to end up having the exponent. What's on the other side of the equal sign, that where it says log equal, remember exponent, log is exponent, x equals, the exponent is x, and that equals the 16. Did you follow that? Okay. That's basically all we've learned about in terms of the log situation. Of course, we have to still figure this out. In this case, sometimes it's less work, sometimes a little more work. We want to find what exponent we should put on 2 to get 16. So remember, I'm going to see how many times I have to multiply the 2 together to get up to 16. So I'm actually using my fingers. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. I had to multiply 2 4 times. In other words, in this case, your x would have been 4. Once it's in exponential form, that usually we can figure it out because we're much more familiar. If the same week that you were taught about exponents, you were taught about logs, you would be as familiar with logs as you are with exponents, and you wouldn't have to always convert. But this is like, I'm trying to think what is it analogous to. Suppose you're in school and you're taught French, but you grew up speaking only English, but you went to a French class and your teacher starts talking to you in French. Unless you're very advanced in French, what you're going to be doing is interpreting. You're going to take what she's saying in French and translate it to English. That's the same thing what we're doing. We're taking log and translating it to exponent. Let's just do one more now. Suppose I gave you this question. Here's another question. Log x equals 2. Try that question. Again, it says log, we want to translate it to exponents. But here, we're missing something. There's supposed to be a number down here, and there isn't. So I told you that means that it's not a mistake. It means that it's understood. I'm going to do it in a different color. It's understood that there's a 10 there. They just don't write in the 10 because you're supposed to understand it. It's what's called a common log. So if I have this log question, then I want to switch it again to the exponential form. Again, the base is this little subscript. In this case, for a common logarithm, it has to be 10. The number on the other side of the equal sign is the exponent. So this says 10 to 2, and that's going to equal the x, what's next to the log. And now this is not so hard to figure out. 10 squared we know is 100. So our answer would be 100. I would say, obviously there's a lot more about logs, just like there's a lot more about trigonometry. There's a lot more about logs that we haven't talked about. We're going to be doing some more with logs. But I would say if there are 5 questions or 6 questions on the final about logs, you probably would be able to get 3 or 4 of them done just by knowing how to switch from the log form to the exponential. Okay. Now I'm asking, does anybody want me to stop or can I go further? Okay. Nobody's stopping me. I'm going further. I'm erasing this and I'm going further. Now, let me tell you, there are, okay, thank you. Okay. I stopped because it said my internet was unstable, but it seems it's okay now. Okay, my next question. How do we use our calculators effectively? There are calculators that allow you to do all this work on the calculator. But I don't know if that's the calculator that you have. And I'm going to go with what I assume is on every scientific calculator. Now, if you look at your calculator, and usually it's on the first column, but you calculate may not be different, you will.
Professor, you're breaking up.
And obviously that's a, am I still breaking up?
Are you seem okay now?
Are we okay now? Okay. I'm just gonna ask if my husband's using the internet. I'm gonna ask him not to. David, is there any, are you on the internet that I'm getting bumped off? Can you please go off? Hopefully this will be better because I just asked him not to use it. Though that's really not fair to do to an accountant when tax day is in about a week. But he said for the next hour he can be off. Okay, so we have this one button on our calculator that says log. If I look at my calculator, I have, my button is right here. It happens to be in the first, but then you're not supposed to be using these fancier calculators. And right underneath it, or right next to it, you might see a button that says LN. It doesn't say IN, it says LN. Those 2 buttons are log buttons, but they're very specific log buttons. There's no button that you can put in on a standard calculator. There are on the specialty calculators, but not on this on these regular calculators. That the only kind of logs you can do on the calculator is this plain log, which we know means base 10 because it doesn't have any base written into it. So if you have a question that has to do with base 10, like if I asked you, find log of 1 million. Let's say I ask you that question. And notice I didn't put any base in it, so I know my base is 10. I can take my calculator and just press my log button and put in 1 million. 1, 2, 3, 4, 5, 6. And when I press enter, my answer comes out to be 6. And of course, that makes sense because remember, the base here is 10, and 10 to what exponent, or 10 to the 6 exponent, is a million. So that you can do. If you want the log, where you a common log of any number, all you have to do is press this log button, and it'll give you the log of that number. Remember, the log being the exponent on the 10 that gives you that number. The exponent of 10 is 6. So the log of a million is 6 because 10 to the 6 is a million. What about the LN button? The LN button is also a log button. Again, I'm mentioning these things, but really for your purposes, it's really more advanced. We probably will do very little using the calculator because these buttons, as I said, are specialized. This is also a log button, but the base of that log, it's called LN, is a special number that's called E. Now, E is something called the natural number. What does that mean, natural number? It's really very unnatural. There's nothing natural about it. It's a number like 2.718 ... It's an irrational number. It goes on and on. It's not a nice number like 10. It's a very strange number that is used in very many applications that have to do with what's called exponential growth, like anything that has to do with compound interest or something of that nature might have a formula with this special number. Instead of writing the whole number out, they just use an abbreviation. They call it E. If you have a log, if you see LN, what it really is telling you is you're doing the log where the base is the special number E. Again, it's important in financial situations. It's important in calculus. It just happens to be, it's called the natural number, but just because it pops up in different places when you do certain operations. I'm not going to tell you why it works. So how does that affect us? Let's say, again, it's unlikely that you would be asked to use your calculator. But let's say I'm looking at an old exam and I see a question that looks like this. Here's a question that they gave. They gave the question this: find ln E. Actually, they didn't even put a parenthesis, e to the third. They gave us this question: find ln of e to the third. Now, obviously, this e is not a variable. This e is a special number, 2.718, et cetera, et cetera. If you press your e, there's an e button on your calculator. If you press it, you'll see it'll pop up something like that. How can you solve something like this? So let me show you how I would go about doing it. I have to remember that ln actually means log base e. So the question I'm really asking you, what is log base e of e to the third? So I don't know what it is, so let's call it x, right? This is what they're asking me to find. This is what my x is. They just gave me find this, right? This is my x. And I know when I have a log question, first thing I'm going to try to do is switch it from its log format to its exponential format. Well, let's see what happens when we go to exponential format on this. Again, ln means log base e, so my base is going to be e. My number on the other side of the word log or ln is my exponent, so this is e to the x. And that equals whatever is right next to the word log, which is e to the third. Well, now we know how to do it because we have the two bases are the same. And we know when we have exponential equations, when the bases are the same, we just set the exponents equal to each other. So it must be that x, or my answer is 3. So yes, there are two special. Could you have put this into your calculator? I think it's harder to stick it into your calculator than to just do it by using what log means. Again, this question, which was on a previous final, all of those questions that we've done so far were answered when we switched from the log format to the exponential format. Okay. So now, what other things could we do with logs? What other things can we do with logarithms? Okay, can I erase this? Is the internet better, by the way?
Yes.
Oh, okay, good. Okay, and I'm still keeping this log thing over there, which is so important to remember. I want to go into something that I sometimes called properties of logs. Of logarithms, or sometimes I call it also logarithmetic. We have to understand when we have questions about logs that really we're dealing with exponents. And when we're dealing with exponents, the rules of exponents aren't exactly the rules of algebra. In other words, you can't just use the distributive property. You have to understand that what you're dealing with are exponents. I'm going to give you basically 3 rules, 3 properties of logs, and then I'm going to show you how we could use these rules to simplify logs, or to sometimes called expand logs. What are those 3 rules? Rule number 1. Suppose you have the log.
Good morning, Ms. Pearl. It's Messiah. I just came in.
Okay, I'm glad you're here. I didn't take attendance yet, so you're okay.
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 And also I saw your email. I am handing work as when I seen it.
Okay, just I'm gonna, as soon as when I'm gonna take attendance, I'm gonna mention it again. Thanks.
Okay.
Great.
All right.
Okay, so our first rule has to do with what happens if we are multiplying 2 numbers. Let's say I'm multiplying the number x times the number y. And it doesn't matter, the base can be any base. It could be base common logs where the base is 10. It could be ln when the base is e, or it could be base of 12 or a half. Any number can be the base as long as it's a positive number. It turns out that the log base b of x times y is the log of b of x base b plus the log base b of y. What am I telling you? When you are multiplying two numbers, what you do to the logs is you add them. Well, think about it. When you multiply two numbers that have the same base, remember when we're dealing with logs, we're always dealing with the same base. When you have two numbers that you multiply and they have the same base, what do you do to their exponents? Remember, the logs are exponents. And we know the rule for multiplying of numbers means you add the exponents. That's why you have to be so careful. When you're working with logs, you're working with exponents. So therefore, if you're multiplying two numbers, what you do to their logs is you add them. That's why this is called transcendental mathematics. Transcendental means beyond algebra. These don't work by the regular algebra rules. Usually when you have two things multiply them, you just multiply them. But that's not what we do here. When we're multiplying two numbers, what we do to their logs is we add them because they are the exponents. So what's rule number 2? Suppose I have log base b of x divided by y. What do you think I should do to the logs of x and y if we're dividing the numbers? Anybody? Anybody have any idea? I'm dividing numbers. What should I do to their logs? Somebody take a guess. No, not flip. Think, what did we do? When we were multiplying, what did we do to the logs? We added. So when we divide, what are we going to do to the logs? No, we did adding when we were multiplying. Yes, Cheryl, that's perfect. You subtract. That means, and that makes sense also, because we know when we're dealing with exponents, if we're dividing two numbers, we subtract their exponents. In other words, this will be the log base b of x minus the log base b of y. And notice it's the top one that gets to be the positive one, and the bottom one is the one that gets subtracted. That's the one with a minus, which you could think about also. The y is in the denominator. In other words, it's as if it had a negative exponent, because that's what a negative exponent means. It was put it in the denominator. Okay, what's the third rule? I'm going to call it the third rule, but really the third rule has two parts. What happens if I had something like this? The log base b of x to some exponent. Let's say the exponent is n. What should we do when we have something? Remember, the log is an exponent, and we're putting another exponent on it. What do we do, let's say, when I have something like this? 5 to the third, and it's raised to the second power. What do we do to the two exponents? If you recall, the rule is what we do to the two exponents is we multiply them. Perfect. This would be 5 to the 6th. Well, the same thing is true over here. This log base b of x is really the exponent. That's what log means. It's the exponent. I just didn't, it's just written in a different way, but the log is the exponent. I'm taking that exponent, in other words, something like the 3, and putting another exponent at it. What should we do to those things? Obviously, we should multiply. So we should take, so what does this mean? This means that we should take this log base b of x, which is one exponent, and multiply it by the other exponent, let's call it n. I like to put it in front because really, you could put it in front, you could put it second, because if I really put it in front, then it just becomes log base b, n log base b of x. I don't really have to put in that parentheses. Or another way of saying it is when you have an exponent, that exponent is going to become, and its logs, you're going to take that exponent and move it to a coefficient. Those are the three main rules of what I call logarithmetic or properties of logs. When you multiply two numbers, you add their logs. When you divide two numbers, you subtract their logs. And when you have an exponent on a log, that exponent gets moved to become a coefficient, becomes the number in front. The exponent here becomes the number in front, the multiplier here. And these rules work backwards. In other words, if I have two logs that are being added, it means that originally what I was doing to the numbers was not adding the numbers, I was multiplying the numbers. Or if I have one log minus another log, the minus in logs translates to division. And remember, the positive one goes on the top and the minus one goes on the bottom, because these rules work both ways. All right, let me show you what type of questions they could ask you that have to do with these examples. And then I'm going to give you one to try as well. Okay, so I'm going to have to erase these rules. But you know what I'm going to do? I'm going to write the rules over here. Right over here. So we'll have them handy. Okay, I'm going to have to write them smaller. Log base b of xy equals log base b of x plus log base b of y. Notice when I separate it into their separate logs, giving you the individual, I have the two numbers multiplied. If I take each of the logs separately, what I do to the logs is I add them. Rule number one. Rule number two, log base b of x over y is log base b of x minus log base b of y. When we're dividing numbers, what we do to their individual logs, when we separate it into their logs, is we subtract the logs. And rule number three, log base b of x to the nth power, the exponent n becomes the coefficient. All right, let's see how, now that I have that all written over there, I can erase this. I'm still leaving this on the board. Suppose it gave me this expression, log base phi of 3xy over z. And the question is, expand using the properties of logs so that we have everything in terms of the individual logs. In other words, instead of having the things all crushed together, we're multiplying, we're dividing, we're whatever, we want to take each of the letters and numbers separately and say what we would do with their logs. Okay, so how do I go about this? I always separate it into two parts. I look for anything that has to do with multiplication and division. And then afterwards, if I have any exponents, I look for exponents. I specifically picked one that didn't have any exponents here. And this 5 here is just going to be something that's carried around. In this case, it's like our B. The B just comes out in the answer. But it could be log base 5, it could be log base 10, in other words, a common logs. It could be ln, which means the base is e. It could be any base. Remember, the base just has to be a positive number, any positive number. I think, what do I see on the top? I see 3 things being multiplied. I see a 3 multiplied times by an x by a y. And I know the rule is that when I'm multiplying numbers together, I add their logs. So that'll become log base 5 of 3 plus log base 5 of x plus log base 5 of y. I change all these multiplications, remembering that things that are written right next to each other are understood to have a time sign in between them. And then I see, is there anything that's divided? And it's being divided by z. That means, and we know when we're dividing, we have to subtract it. So that'll be minus log base 5 of z. This is what it means to expand an algebraic expression in terms of its logs. If I give you a log of one thing and I ask you to expand it, just remember those 3 rules. When you're multiplying numbers, you add the logs. When you're subtracting numbers, when you're multiplying numbers, you add the logs. When you're dividing numbers, you subtract the logs. And when you have exponents, they become coefficients. Let me do one more and then I'm going to give you one to try. Okay. Can I erase this?
No, wait a little bit.
You have a question?
No, don't erase it.
Okay, I'll leave it on. You know what? Let me start taking attendance then. And I'll leave this on the board. I'm going to put the next question. I'm going to write the next question that I'm going to do. I'm not erasing this, but I want you to see the next type of question we're going to do. We're going to do the same thing with something like this. Log base 2 of x to the 4th over square root of y times z to the 3rd. Okay. Okay. Now let me ask you, could I erase it now or are you still copying? Azia?
Yes, Professor. Yeah, you can erase
I
it
can
now.
erase
Yes, thank you.
Okay. So now I'm going to erase it. I'm going to work on this problem. And then I'm going to give you one to try. Again, remember the 3 things I'm looking for. I'm looking for multiplication, division, and exponents. And first I look for multiplication and division. I'll worry about the exponents afterwards. So if I look at this, the first thing I see is that I have an x to the fourth, and it's divided by square root of y times z cubed. So what will that mean in terms of the logs? Let's just talk about the multiplication and the division. We'll worry about the exponents at the end. That means that I'm taking the log of x to the fourth, and I'm going to subtract, because I'm dividing it, I'm going to subtract it by, and I'm going to put a parentheses because I'm subtracting it by this whole thing, the log base 2 of the square root of y plus the log base 2 of the z to the third. That's just using the rule when I'm dividing, because that's what I'm doing, I subtract their logs. Now notice on this one, I had to subtract this whole thing, and this whole thing had some multiplication in it. So that's why I added these two logs together, but I'm subtracting it all, put it in parentheses, because it's being subtracted, it's being divided, the x fourth is being divided by this whole thing. Okay, next step. I'm going to look for exponents. That's my next step. I'm going to look for step 3. Now, except one of my things had a square root. And I didn't give you any rule that has to do with the square root. So let's think about it. Before I go any further, what does the square root of y mean? Actually, when this chapter on exponents and logs, this chapter 8 that we're doing now, there's no mention of the radical sign. If you see a radical sign, you have to write it as an exponent. Remember, we said a square root of y is the same as y to the 1/2. The cube root of the index here would be 3, then this would be 1 to the third. The fractional exponent is the same as the radical. So if I rewrite this thing, this really is saying log base 2 of x to the fourth minus, okay, here's my parentheses, log base 2 of y to the 1/2, because the square root of y is the same as the 1/2 power, plus the log base 2 of z to the third. Okay, let me erase this so we can go further. And I remember that what I said about exponents, when we're dealing with logs, if there's a log and then there's something with an exponent, that exponent becomes a coefficient. So this 4 is going to go in front of here. This 1/2 is going to go in front of here. And this 3 is going to go in front of here. That's what rule number 3 tells me. That when I have an exponent, bring that exponent to the front in front of the word log. So the next step, we do 4 log base 2 of x minus, here's my parentheses, 1/2 log base 2 of y, because this 1/2 is becoming the exponent, the coefficient, and this 3 plus 3 log base 2 of z. And that's what we mean by expanding something in log format into its individual logs. This is equal to this. This statement is telling us what we should do to each log in order to get the log of this whole complicated expression. See, I'm going to give you one to try on your own. Okay, so here's the example I want you to do. Write it over here. I want you to do a similar thing. I have log base 3 of the square root of x over 9y squared. See if you could write this, just like we did this one. Can we write this in terms of its individual logs? Again, I'll read it. Log base 3 of square root of x over 9y squared. This is probably the hardest part of logs. Let me just tell you though, at most it's going to be one question. I'm going to go into something where this is much more useful in a second.
Can I ask you some of the question? Is this whole chapter or this objective is a look into pre-calc, correct? No?
This you definitely need for pre-cal, and you're going to need it for cal.
Okay.
That's why it really is an important chapter. Actually, my feeling is that they should have stopped just at the definition of logs, but I have to do what the syllabus says. I think this is a little bit too complex for this course, but as I said, it's going to be at most one question. And I want to show you how to do the question, but if you really are totally confused, you don't have to worry about it too much.
Okay.
Okay,
I
and
get
remember, you're going to be getting it as a multiple choice question, so you won't have to actually do it. You'll just have to recognize what makes sense. Next time, I'm going to bring in actual questions with multiple choice, so you'll get an idea of that.
Okay.
Okay, don't worry too much about it. I know this is the hardest part that I have to teach about logs, but I'll keep repeating. What you're doing to logs is what you're doing to exponents. So if you're multiplying numbers, you've got to add the exponents. When you're dividing the numbers, you got to subtract the exponents. And when you have an exponent, it has to be a multiplier. Those are the basic rules of exponents. Okay, I'm going to take attendance. And then I'm going to go a step further. Azia, you're here. Nashia Allen. Nashia,
Yes, I'm here.
what?
I said I'm here.
I knew you were here. I spoke to you before. Is Nashia here? What about Anna Belkis? Emma, I know you're here. Messiah, you're here. Corey Brown.
I'm here.
Good. You got my email?
Yes.
Yeah. April.
Present.
You're here, April?
Yes.
Good morning.
Good morning.
Khadija? Khadija? Umar. Umar Diallo? Yakima? Yakima? Cheryl, I know you're here. Stacy, I'm pretty sure you were here. Did I see you, Stacia? Stacia?
I'm here, Professor. Sorry about that.
Okay, good. I thought maybe my internet went down again. Denisha is not here. Devana.
Hi, Professor. I'm here.
Natalie. Natalie, you're here? Good morning. Erica, I know is here. Jonathan, I know is here.
Yes, I'm here, Professor. Erica.
Hi. Oh, you're back. Good. Is Luke here? Luke here? Try to look on the.
Here.
Oh, good. Okay. Layla. Layla Naji. Okay, I'll see Layla. Ashley, I see.
I'm here.
Good. Good morning. Kachira, I know you're here. Jennifer, I know you're here. Rachel. Rachel here? Okay, I guess Rachel's not here today. Okay, before I do this problem, I just want to repeat for those of you who got emails from me, I went through everybody's records. Thank God I don't have 90 students this term. It's much easier for me to deal with. And I checked. In order to get full credit for classroom work, homework, and class tests and quizzes, you had to do at least 15 of the homeworks on Delta Math. And there have been a total of 6 quizzes and tests that are not the midterm or the final. I'm not talking about those. Those are departmental. My personal tests, there were 4 on Delta Math and there are 2 on Blackboard. I just opened up the last one, the one that's on conics and trigonometry yesterday in the afternoon. You have until next week to do that. You have, out of those 6, total of 6, in order to get full credit, you have to have done 5. If you've done all 6, then I will drop your lowest mark. I also said there is a practice final. If I see that your practice final, and I'm giving you 2 attempts to do it, so if you don't do well on the first one, you could do it a second time. I'm not giving you more than 2 attempts. It doesn't make sense. If your mark on your final, let's say you have a test mark out of you did 5 tests and 1 mark was a 50, and then you come up and you did this practice final and you got a 90, I'll scratch that 50 and put 90 in place of it. I'm not making that practice final mandatory. I just think it makes more sense to do it. If you want to know what's going on, if you want to see how your final is going to be, all of this, what I did is I went and if you already had all the information, if you had at least 15 homeworks and you had 5 tests done, I didn't send you an email. I sent an email to people saying, if you're missing work, and I said specifically, you're missing, let's say somebody had only done 9 homeworks. I wrote, you're missing 6 homeworks and you're missing 2 quizzes, so that you know what you have to make sure you look. It's there on your Delta Math account. It's also available on your Blackboard account. So between the 2 of them, you should be able, but I told you what to look for. Okay, Jennifer, you had a question.
Yeah, on the final, it's gonna be 40 questions also.
No, the final is going to be 30 questions.
Okay.
There's going to be 30 questions and you're going to have 2 hours to do it.
And this quiz that you just posted, how many questions does it have?
10.
Okay.
Okay. Now, if it turns out that you only did 4 of them and you also did the practice final, then I'll consider that you have done all the work. I still think it makes sense. So you're just going to, the effect of doing extra tests is that you get the better marks, because I will pick out the best marks. If you've done, I'll pick out the 5 best marks that you have. Okay. And don't forget, our final exam is May 20th. That's 2 weeks from yesterday. We have 1 full week of class after today. Okay, so what? Okay, so let's look now that let's look at this problem and see if we can figure it out. Again, I'm not going to spend a lot of time on it because you're going to see that actually there aren't too many questions about it. If you totally don't get this, it's 1 question. So I asked you to figure out what the log base 3 of the square root of x over 9y squared. And remember, I'm going to do this in steps. First of all, once I see a radical, I want to rewrite that. Let's not write it as a radical. Let's write it as an exponent. It really means x to the 1/2 over 9y squared. We have no rules for radicals. We do have rules for exponents. That's that 3rd rule. So anytime you see a radical, write it as an exponent. Okay, and then I first look for anything that involves multiplication and division. Now, what I see is this x to the 1/2 is being divided by 9y to the 2nd, which means that I'm going to have to subtract those logs. It's going to be the log base 3 of x to the 1/2 minus, and I have to put it, it's going to be the log base 3 of 9 plus the log base 3 of y squared. Notice, here is a division, here is a multiplication. But if you notice, I put a minus in front of the whole parentheses because this whole thing is in the denominator. Okay, that's step 1. Step 2, I look for exponents. And I do see exponents. Here's an exponent. And on the y, I also have an exponent. And I know with an exponent, the exponent is going to come in front. So it's going to be 1/2 log base 3 of x minus log base 3 of 9 plus, now that 2 is going to come in front, 2 log base 3 of y. And if you got this far, that's amazing. There actually is something more that we can say. And that's this log base 3 of 9. Actually, I can figure out the number that log base 3 of 9 is. How do I figure it out? Let's call it A. I don't know what it is. I'm going to show you that I can figure it out. Because log base 3 of 9 equals A is the same thing as saying my base 3 to the exponent A is going to give me 9. I went from the log format to the exponential format. I can do that because these are only numbers. There are no x's and y's, so I can do it with numbers. But if I think about it, 3 to what exponent will give me 9? And I know that that a would have to be the exponent 2, because 3 squared is 9. In other words, this log base 3 of 9 is the number 2. So in place of this whole thing, this whole complicated expression, I could just put the number 2, because that's what it's equal to. So in the final step, this would be 1/2 log base 3 of x minus parentheses 2 plus 2 log base 3 of y. Notice this is a minus in front of a parentheses. I'm going to erase this so I can write further. Alternatively, I could have removed that parentheses and say it's 1/2 log base 3 of x. Remember, this is like a -1 in front of it. So -1 times 2 is -2. And -1 times this 2 is -2 log base 3 of y. And here, both of these answers are correct, this one or this one. This one has a parentheses, here the parentheses is removed. Notice both of these have minuses because both of those came from the denominator. Anything on the top is positive, anything on the bottom is negative. Does anybody have a question about this? Okay. What's more important for us is actually how this affects us if we're going to be solving logarithmic equations. Okay. Can I erase this?
1 second.
This I will definitely go over again on Tuesday. But again, if you do the practice final, you will see there's maybe one question like this. There is not more. Okay, can I erase it now?
Yeah, go ahead.
Okay, thanks. We actually talked a little bit about solving equations that have logs in them. I'm going to do 2 other types of questions so that we'll see what type of equation questions you could have. Suppose I had an equation that looks like this. Log base 2 of x plus 3 plus log base 2 of x equals 3. Here is a log equation. And it's not exactly like the log equations that we were dealing with until now, because when we were dealing with log equations, let's say we had something like log base b of A equals C, which was our basic log equation. You had a log with a base with something next to it, and it equals C. We usually what we did is we went to the exponential form, and we did B, our base, to the C exponent is going to give us A. The problem with doing it with this one is because I don't have just one log. I have multiple logs on this side. If I just had the log on the word log on this side and a number on that side, I'd go right to the exponential form. But what happens when I have more than one log on a side? So here's what I have to do. Before we had one log and we expanded it to multiple logs. Now we're going to take multiple logs and contract them, put them back to a single log using the backwards reasoning. Here we have the two logs being added, and we just said, when do we add logs? When do we add exponents? When we were multiplying numbers. In other words, this is the same thing as writing log base 2 of the x plus 3 times the x. If originally I must have been multiplying this by this in order for us to have been adding the logs. So what I do is, when I see more than one log on a side, I contract it back to a single log, remembering that when I see plus an addition sign between the logs, it means the numbers are being multiplied. If this would have been a minus, it would have meant that I was dividing. That's exactly these rules, only starting at the right side and working back to the left side. It's going backwards on them. But once I have this contracted to a single log, I can then change it from the log format to the exponential format. Remember, I said most of the questions you're going to get will be easier to do if you can switch it from the log format to the exponential. Well, let's see how we'll go to the exponential on this. Again, remember, the subscript is my base. The number on the other side of the equal sign, the word log means exponent. Log equals means exponent equals. The exponent is 3. And that equals the x plus 3 times the x. In other words, I've gone from a log equation to a regular algebraic equation, and I've got to solve this equation. Okay, how do we solve this equation? So I just remove the parentheses and simplify the numbers. What does 2 to the third means? It means 2 times 2 times 2, which is 8. And x plus 3 times x, I'm using the distributive property, will be x squared plus 3x. Something's wrong here. I don't know where I got this from. Oh, I'm sorry. This is supposed to be a 2. I knew there was something wrong with it. Sorry. Sorry, I copied that wrong. So we're getting 8 equal x squared plus 2x, because x plus 2 times x is x squared plus 2x. And that means that we have a quadratic equation. Now we have a regular equation. I have to get it equal to 0 because it's quadratic. So I'm going to subtract. Notice I'm subtracting the 8 rather than this because it's easier to go that way, which will give me 0 equal x squared plus 2x minus 8. And this can be factored. Remember, we're looking for my AC is -8. So we're looking for two numbers that multiply to 8 and subtract to 2, which is 4 and 2. And it's going to be x squared plus 4x. The 4 is going to be the positive, minus 2x minus 8, which gives me x times x plus 4, minus 2 times x plus 4. And that gives me my x plus 4 times my x minus 2. That's what's equal to 0. Notice how see how many things we're using. We're using our logs, the properties of the logs, to write it to single logs. We're using our definition of logs to change it from log form to exponential form. And now we're remembering how to solve a quadratic equation, which we learned earlier. Of course, that means the x plus 4 equals 0, and the x minus 2 equals 0. So x equals -4 is one answer, and x equals 2 is my other answer. I got two answers for x. Let me put them up here. X equals -4 and x equals 2. But, and here's a big but, if you remember what I said when you're doing logs, you can have the base has to be positive, and what you're taking the log of, the number that's next to the word log, has to be positive. The only thing that can be negative is the exponent. And look what happens. If I pick x to be -4, then this will become -4 plus 2, which is -2, and that isn't allowed to be. But when x equals 2, 2 plus 2 is +4, and this is also positive. So therefore, we have one answer that works. This is the only answer. This answer we had to reject because we can't take the log. We can't have the number that's next to the word log ever being either 0 or negative. It has to be a positive number. Okay, now I'm going to give you one to try. I'm going to giving you one from a final, and I'm going to give it to you as a multiple choice question. I'm going to give you a few minutes to do it. Okay, can I erase this? Anybody who still need it on the board? Okay, so then I'm going to give you a new problem. I want you to solve this equation. Log base 2 of x plus 7 plus log base 2 of x minus 7 equals 3. Okay, so log base 2 of x plus 7 plus log base 2 of x minus 7 equals 3. Here are your choices of answers. Multiple choice. Square root of 57, 57, 8/3, and 101 divided by 2. These are the possible answers they're giving you. See if you can do that question and see if you can come up with the right answer. Layla, I am marking you present here.
Ms. Weinberg, I have a question. On the final exam, how many questions in regarding to the logs will we have on the final exam, if you know?
I don't know for sure, but I would guess around 5.
5, okay.
Okay.
Mm-hmm.
And one of them will be something like this, and one of them will be like one of them, like that whole thing. The rest will be just standard switch from log. Might be even a question, write this in exponential form.
Okay.
So some of them, I'd say of the 5 questions, 3 of them are quite easy. It's just 1 or 2 that could be difficult.
Thank you.
Again, I think at this point you should be able to do all the questions. At this point, I think I've taught all the material that is on that practice final. I still am going to do a little bit more with logs on Tuesday. And then the rest of the week, I'm going to spend reviewing. That's why I'd like you to say, I know, I'm trying to think, was it Kashira who said she wanted to do some more on the Pythagorean theorem? If there are topics that you feel you still need more help with, please either send me an email or say it at the beginning of class. Please review this particular topic so that we go through the topics. We have completed reviewing through chapter 1 through 5. So we really do have 4 chapters to review still. The radicals, the quadratic equations, the trigonometry, and the conic sections, which again, there is a test of 10 questions on conic sections and trigonometry. Good to do these things as a review. Again, on that test, I also gave you 2 chances to do the quiz, and that the mark I'll see is the better of your marks. Okay, let's work on this together. And again, I have logs on one side and a number on the other side, but I can't switch it to exponential form until I have just one log. So I see, since there's a plus between the logs, I must change that to a multiplication. This is the same as saying log base 2 of x plus 7 times x minus 7. Remember, when I'm adding logs, it means I'm multiplying the numbers or the expressions. And when there's a minus in between them, it means I'm dividing. And this is equal to our 3. So now when I have, it says a log equaling a number, I can go to the exponential form. Again, the base here is 2, so that's my 2. The number on the other side, the 3 is my log, is my exponent, so that's 2 to the 3rd. And that equals the x plus 7 times the x minus 7. In other words, we change the answer. We change the example from a log equation to a regular equation without logs, a regular algebraic equation. And let's see what we get. This says 2 to the 3rd, which we know is equal to 8. And we want to remove the parentheses, and these are conjugate binomials, so I don't even have to do the whole FOIL. I can just do first and last. X times x is x squared. 7 times 7 is 49. So I get x squared minus 49 on this side, because again, I don't have to do outer and inner, they're going to cancel out. And I'm going to bring this 49 to the other side so that I get 8 and 49, which is 57, equals x squared. And if x squared equals 57, we know we use the square root property. That means the x would either be plus or minus the square root of 57, but we can't use a negative one because this is a log, so we only have the positive 57. And that's choice A. Did anybody get choice A as a choice?
Professor, what's the name of this? Like the name of this whole operation?
This is called logarithmic equations, or
Okay.
log equations. Log equations. Okay, I'm going to stop here. Melissa, are you continuing with them?
Sorry, Professor, I can't do it today.
Should I make you the host?
I can't do it today, Professor.
You are doing it?
I can't do it today. Are you hearing me?
Okay, now I hear you.
Oh,
Okay,
sorry.
so I'm going to end the session. Next week, Melissa will have sessions for you.
Yeah.
If you have any topics, either bring them up to me or bring them up to Melissa. Look at I would say at least spend some time looking at that practice final so you know exactly where you have to concentrate. Again, if you got an email from me that you're missing work, make sure you finish up the work. Obviously, the quicker you finish it, the better it is for all of us. But you definitely have to finish it before the final, because if you're still missing work, I'm going to count that in your final grade. Okay, any questions?
Now, happy Mother's Day.
Thank you. Thank you.
Happy Mother's Day to everyone, every mom in here.
Everybody who is a mother, grandmother,
Oh my God, what's happening?
mother, happy Mother's Day to everybody. And if you have a mother, treat her.
The same to you. Thank you.
Cheryl,
Yes,
from me, say happy Mother's Day to your mother.
will do. Thanks much.
Have a great weekend, everybody.
You too. Bye-bye.
Bye-bye.
Bye.
Right.